In the vast expanse of the cosmos, the James Webb Space Telescope has uncovered something that defies explanation. They call them the little red dots. Since their discovery in 2024, these tiny crimson specks have become one of the most perplexing mysteries in modern astronomy. What are they? The answer could rewrite everything we know about the early universe. The James Webb Space Telescope was designed to see the first stars and galaxies that formed after the Big Bang. It peers deeper into space and further back in time than any telescope before it. And what it found was unexpected. Scattered across the ancient universe, appearing between 600 million and 1.6 billion years after the Big Bang, were hundreds of small, intensely red objects. They were compact, incredibly bright, and utterly baffling. By 2025, astronomers had catalogued over 340 of these little red dots. And they have been struggling to explain them ever since. The first theory was that they were active galactic nuclei. That is, young galaxies with supermassive black holes at their centers, furiously consuming gas and dust. This would explain their brightness and their red color. The intense gravity of the black hole would heat surrounding material to extreme temperatures, creating a brilliant glow. But the little red dots did not behave like normal active galactic nuclei. They emit almost no X-rays, which is highly unusual for a black hole-powered system. Their infrared spectrum is flat, not steeply rising. And they show almost no variation in brightness over time, while most black holes flicker and flare like cosmic lighthouses. Something was clearly different. In July 2025, a radical new theory emerged. What if the little red dots were not galaxies at all? What if they were individual stars? Not ordinary stars, but supermassive primordial stars. The first stars of the universe. Known as population 3 stars, these hypothetical giants were predicted to be enormous, perhaps 1,000,000 times the mass of our Sun. They would have formed from the pristine hydrogen and helium left over from the Big Bang, containing almost no heavier elements. Theoretical models showed that these supermassive stars would produce a spectrum that matches the little red dots with remarkable precision. The V-shaped Balmer break, the broad emission lines, the unusual colors. Everything fits. If this is true, we are not looking at galaxies. We are looking at individual stars, each 1,000,000 times more massive than our Sun, burning in the darkness of the early cosmos. These primordial behemoths would have lived fast and died young. Only a few thousand years, a blink of an eye in cosmic terms. But in their death throes, they would have collapsed to form supermassive black holes. This would explain another mystery. How supermassive black holes appeared so early in the universe's history. The seeds of these monsters may have been the little red dots themselves. The alternative theory is that the little red dots are quasi-stars. A hypothetical object consisting of a black hole surrounded by a massive envelope of gas. Not quite a star, not quite a galaxy. Something in between. The black hole at the center would consume the gas from the inside, while the outer layers would shine brightly. These objects would be incredibly rare today, but may have been common in the early universe. One of the most intriguing little red dots is nicknamed the Cliff. Discovered by the RUBIES survey, it shows a prominent Balmer break that suggests it might be a black hole star. A star with a black hole at its core. The Cliff provides the clearest evidence yet that at least some of these objects are not ultra-dense galaxies, but are powered by a central ionizing source embedded in dense, absorbing gas. Another remarkable object is Kuiper's LRD-Z9. This little red dot has been confirmed as a broad-line active galactic nucleus at a redshift of 9.288. It is the highest redshift active galactic nucleus ever discovered. A supermassive black hole seen when the universe was only a few 100 million years old. Its existence challenges our models of how black holes grow so quickly. The little red dots are incredibly compact. Most are no more than 500 light-years across, and many are smaller than 150 light-years. For comparison, our Milky Way galaxy is about 100,000 light-years across. These objects are tiny, dense, and intensely bright. They represent a population of cosmic objects that we simply did not know existed before JWST. The RUBIES program, which stands for Red Unknowns Bright Infrared Extragalactic Survey, has been at the forefront of studying these objects. Led by Anna de Graaf and Gabriel Brammer, the program has observed hundreds of these red sources in deep space. Their findings have only deepened the mystery. The little red dots contain much less hot and cold gas than models predict, pointing away from both active galactic nuclei and star-forming galaxies. There is even evidence that the little red dots may be the product of galaxy mergers. Of the complex ones studied, about half showed multiple components, and the rest showed highly asymmetric structures. This suggests that these objects may represent the early stages of galaxy and black hole growth, captured in the act of formation. So what does this mean for our understanding of the universe? If the little red dots are supermassive population 3 stars, they represent the very first generation of stars ever to exist. These are the objects that ended the cosmic dark ages, the first sources of light in a universe that had been dark for hundreds of millions of years. Their discovery would be one of the most important in the history of astronomy. If they are early active galactic nuclei, they show us how supermassive black holes formed and grew in the infant universe. We are seeing the birth of the monsters that now lurk at the centers of every large galaxy, including our own Milky Way. The seeds of these giants were planted in the first billion years after the Big Bang. The little red dots also raise profound questions about our models of galaxy formation. How could such compact, bright objects exist so early? How did they form so quickly? What happened to them? Why do we not see similar objects in the nearby universe? One theory is that they undergo inside-out growth. As the galaxy evolves, less gas is deposited near the black hole. The black hole sheds its outer layers, becomes bluer, and is no longer classified as a little red dot. Local analogues may exist in the form of green pea galaxies. These are small, compact galaxies that glow green due to intense star formation. Some of them host broad-line active galactic nuclei and show the same V-shaped spectral energy distribution. These local analogues may hold the key to understanding the little red dots. The James Webb Space Telescope continues to observe these enigmatic objects. Each new observation brings more data, and more questions. The little red dots are a reminder that the universe is far stranger and more wonderful than we can imagine. They are a testament to the power of exploration, and the endless surprises that await us in the darkness. In the coming years, astronomers will continue to study these mysterious red specks. New surveys, new instruments, and new theoretical models will gradually peel back the layers of the mystery. But for now, the little red dots stand as one of the great unsolved puzzles of modern cosmology. The universe is speaking to us in a language we are only beginning to understand. And the little red dots are its most intriguing message yet. What are they? Stars, black holes, or something entirely new? The answer is out there, written in the light of the most distant objects ever seen. And the James Webb Space Telescope is finally allowing us to read it. The story of the little red dots is far from over. In fact, it has only just begun.